Okay, so today's lesson is looking at independence. It's kind of been touched on in a few of the other, particularly probability trees, about what independence is. It's another one of these things that, like mutually exclusive, that you can actually test for in some of the questions. So that's going to be the main focus, but you also got to have a good understanding of the overall idea of what independence is. So just to start off with, I'll give you a definition. So, independent events. Events are independent if their occurrence of one event makes no difference to the probability of the second event. Um, so I've got an example here. So independent events would be looking at the probability you live in Christchurch and that you shop at the warehouse. So they have really no effect. If you live somewhere else in the country, you probably have about the same probability that you shop at the warehouse, because you can do it online. The warehouse is fairly ubiquitous all over the country, so there's no real disadvantage or advantage of being in Christchurch to have more access, or any reason why there'd be a greater probability that you're in Christchurch. Things that are more dependent is a bit more specific. So the example I've got, that you live in Christchurch and you shop at Riccarton Mall. For instance, if you live in Auckland, you're less likely to shop at Riccarton Mall than what you are in Christchurch. So that first event, or the outcome of the first event, whether you live in Christchurch or not, will change the probability whether you shop at Riccarton Mall quite large. Thinking back to the independent, where it had a very little effect at all. So I've got a bit of a task here. What I want you to do is just pause the video, have a read through, choose from these 4 outcomes, and try and have a go at guessing whether they are independent or dependent. Okay, hopefully you had a go. So the first situation, you flip a coin, then you roll a fair 6-sided dice. The coin lands, heads up, and the die shows a 1. So are those independent or dependent events? Did the probability of what you got on your coin affect what happened to the die? And of course it didn't. So that first one we say is independent. Number 2, a bag of 8 red marbles and 4 blue marbles. You randomly pick a marble, and then you pick a second marble without returning the marbles back to the bag. The first marble is red, the second marble is blue. So did the outcome of the picking the second marble, was that affected by what you chose at the start? And yes, it was, and they are dependent on each other. And it's because we didn't replace that marble that we chose at the start. By taking a red marble out of the bag, suddenly there's a greater chance of getting a blue marble the second time. Had we chosen a blue marble to start with, there would be less of a chance of getting a blue the second time around. So they're dependent. Next one, box of chocolates, 5 chocolates, milk chocolates, 5 dark chocolates, 5 white chocolates. You randomly eat 3 chocolates. The first piece was a milk, second was a dark, and the third was a white chocolate. So obviously that's a fairly similar scenario to the previous one. That is dependent as well, because if you had chosen a white chocolate to start with, then the probabilities of everything else would have changed. To change that question, to make them independent for number 2 and number 3, is that we would have to replace our values. Number 4, a cooler contains 10 bottles of sports drink, 4 lemon lime, 3 orange flavored, 3 fruit punch. 3 times you randomly grab a bottle and you return the bottles to the cooler and mix them up. The first time you get a lemon drink, the second time and third times you get fruit punch. So obviously they're independent because we're returning. So the important part of identifying whether an event's independent or dependent or not is because the actual probability or the formulas and all our understanding is different from each event. If if events are independent, it means that the probabilities don't change through however many occurrences or events that we have. So there's less calculations that we have to do. Now, Dr. Nick's done another video explaining about combining independent events. Have a watch of, you should have watched that already, but if you haven't, go back and have a look at it, and hopefully that can help your understanding as well. So go back and have a look now. Otherwise, we'll carry on. So hopefully giving a bit of a summary of the main ideas of looking at independence and dependence. So the probability that both event A and event B occur is given by the AND rule. Okay, the probability of A is equal to the probability of A given B, which we've talked about in conditional probability already, times the probability of B. So the way it's given in the exam is it's given in this form. It is helpful to be able to interchange and move and manipulate the formula to what you need, because if you know one of the values, you can work out the other. Okay, so one important thing about independence though, and the law of conditional probability, that if B has no effect on A, so in other words, this A given B, we say is the probability of A. So for instance, going back to our original example, given that the person shops at the warehouse, what is the probability that they come from Christchurch? Because those events are independent, the warehouse part has no effect on it all. So we say that it would be the probability of being in Christchurch or picking a person that's from Christchurch. If the events are dependent, so for instance, so given that they shop at Riccarton Mall, then the probability that they come from Christchurch won't be the same. So then you couldn't use that. So if events are independent, we can basically forget this part and change the formula so it looks like this. In other words, if you multiply their individual probabilities together, you get the intersection, or the AND, the probability of A and B. So if we want to know the probability that a Christchurch person, you randomly select a person, they're from Christchurch and they shop at the warehouse, you just multiply their individual probabilities together. So in summary, and these are the bits you probably need to make sure you've got clear. For independent events, you can use that formula. For dependent events, you have to use this formula. So that's really important when you think about making that choice on whether something's independent or dependent will determine which formula you use. So let's have a look at some questions that we can do. So the key thing is you've been asked is determine if these events are independent. Well, if they're independent, this must be true. So the probability of A and B should equal that. In other words, it should equal 2 over 25. So the big question is, does 2 over 5 times 1 over 5, does it equal 2 over 25? Yes, it does. Okay, look at this scenario here, same thing again. that we should be able to go 2 over 5 times quarter. What does it equal? Equals 1/10. So probability of A times probability of B doesn't equal 1/25. So dependent. Okay, and that's basically it. So sometimes in questions they may ask you to get that information from a table, or it might be a paragraph or something like that, but it's trying to identify that test of independence. Likewise, you might get a question like this where you're told that these are independent, so you need to find the missing probability. So we have to think about what the rules are for independence. So independent means that probability of A and B is equal to probability of A times the probability of B, and also that the probability of where is it? The probability of AB is equal to A. Probability A. So looking at the question there, obviously that top one's not going to help us, but we're looking for the probability of B given A. So using this formula, then the probability of B given A should equal the probability of B, which is equal to 3/5. Likewise with question 14 here, we've got our two formulas, probability of B, probability of A given B. So probability of A must be equal to the probability of AB because they're independent, which is 1/5. And that's our answer. So it's not good enough to find the probability, you need to explain how you got it as well. So there's some work there to complete on this stuff on the lesson, so go back there and make sure you give it a crack.